Effect of mass of nucleus on Bohr's model of a hydrogen atom. So in the Bohr's model of a hydrogen atom, just if we discuss about atomic spectra of hydrogen like or hydrogen atoms. So very first case in a atomic spectra of hydrogen and hydrogen like atoms. So hydrogen like atoms, a very small deviation is occurred. A very small deviations are occurred. It means hydrogen like spectra. This is what hydrogen like atoms or hydrogen atom. So this is what hydrogen like atoms means what? It's a like lighter atoms. It means hydrogen. Next one is helium, He plus 2 if you remove then. So what will be? 2 electrons are removed. But He plus 1 if I do this, so number of electrons will be 1. This is what hydrogen like atom. So in the hydrogen atom, number of electrons are 1. So He plus also number of electrons are 1. In lithium, Li plus and plus. Okay, so then also we can say hydrogen like atoms. So I can say you that this is in a hydrogen like atom. So H, yes, hydrogen like atom. So this is hydrogen like atoms are. Okay, so first one helium He plus lithium plus plus. Okay, so like we can take it. And next one, just the assumption. So it's a first condition. And second one, in the effect of a mass of nucleus on Bohr's model, this is just assumption that nucleus, only assumption. Okay, just assumption that so then what? Nucleus mass, it's a nucleus mass is infinite, as compared with mass of electron, So mass of electron is, so the mass of electron it is which is very small, and mass of the nucleus as compared with this, so it is what? Infinite. But practically infinite, is it possible? No. As it just comparing with this mass of electron, mass of nucleus is what? So like such a bigger one, and mass of electron is smaller than of this mass of nucleus. So this is the reason, based on this reason we are saying that nucleus is at rest. Okay, it's a heavier mass. I'm considering it's a nucleus is at rest. If the nucleus is at rest, okay, so then nucleus is at rest means here only these theoretical conditions we are talking about this. So nucleus is at rest with respect to, okay, so with respect to electron, it's what? Electron. Okay, so next one, in just actual situation is what? Let us see that. So practically, if you observe this, it's a practically nucleus mass is practically nucleus mass is not infinity. It is not infinity. So it is not infinity, but both nucleus and electron revolve. Okay, it's very important. It is not infinity. Not infinity for the practical situation means then nucleus. Okay, so nucleus and electron, can form as a system. Okay, So this system moves, that means revolves. It revolves around center of mass. It revolves around center of mass. Okay, so just let me go on this. So it revolves around the center of mass. Around the center of mass. It means, for example, this is, if I choose a particle, here is the point. Okay, so here some mass is taken. It's a capital letter M. Is a capital letter M is the mass, and so the mass of the nucleus is taken. It's a capital letter M, and next one. So mass of electron. So when you speak about it's a mass of electron, it's a small letter M. Okay, so their center of mass. The center of mass, this capital M, and next one is a small m. So this total distance is what it's a r. Okay, it's what r. And next one, this distance is r1, and this one is what r2. Okay, so with respect to center of mass, it revolves. With respect to means what? It forms like this is one. Okay, next one. So they can revolve with respect to center of mass. Where is the center of mass? Cm. The center of mass is what? It's a Cm. So from here, if you want to write about R1, okay, R1. R1 is what? Distance of center of mass for small m. Distance of center of mass from electron. Okay, so distance of center of mass from electron is what? So this is what M1 is equals to capital M into R by capital M plus small m. Okay, is the first one. And R2 is equals to small m into R by capital M plus small m. Capital M indicates what? Mass of nucleus. Small m indicates what? Mass of electron. Okay. So from this slide, what just I discussed it. It's what practically, if you discuss about for the practically. So mass of the nucleus is infinity, means it is practically it is not possible. This is what not infinity. Not infinity means what? We are talking about electron, and next one is the nucleus. Both are two particles. They are moving like a like a system with respect to the center of mass. So this is what electron. Next one is what? It's a nucleus. Sorry, this is what nucleus, and this is what electron. Its center of mass is this. This is the center of mass. This distance is what? It's a r1. It's what? R2. So they are moving with respect to the this. Okay, like so. This is the center of mass, and distance of center of mass from electron is what? R1. Distance of center of mass. Okay, so from electron, and distance of center of mass from the nucleus is what? R2. Sir, why this part is closer to this one? Center of mass is always closer to the heavier mass. Okay, so R1 is equals to capital M into R by capital M plus small m. R2 is equals to small m into R by capital M plus small m. We can write this. Next one, continuation from before slide. So for for both, for both the electron, for the both electron and the nucleus, electron and nucleus. So they are moving in circular path. Means what? The necessary, okay, necessary centripetal force, necessary centripetal force, okay, to revolve, so in circular path, to revolve in the circular path. So then what happens this? So for example, the center of mass is moving in the circular path. It moves in the circular path. So is a point from here. This is, for example, first one I'm taking about, it's what? This is the R1, okay, R1. So next one, earlier case I'm talking, this is what? This is what? Electron. And next one is, so one second, it's what? For example, nucleus here. So this is the nucleus, it's a capital M. Its mass is what? A small letter m. So this is removed. It's what? A small letter m. Okay. So this is its center. This will be like is the case. Okay. So now we can write with respect to this small m, if you talk about, so it is balanced by the central force. Central force means what? For electron, if you write, so m r1, okay, omega square, mr omega square, that's what Fc is balanced by electrostatic force. Fc means what? Centrifugal force. Centrifugal force is mr1 omega square is equals to 1 by 4 pi epsilon naught ze square by, it's a r square. Okay. So now, so what is the r1? So r1 means what? M into, so r1 already we got this one, capital M into small r by, that's what? M plus m omega square is equals to 1 by 4 pi epsilon naught, it's a ze square by r square. Okay. So from this relation we can write this. From here we can write, so that's what mu into r cube, okay, r cube omega square is equals to, it's a ze square by 4 pi epsilon naught. Okay. So this mu means what you say? It's a reduced mass. Okay. It's a very important, reduced mass. Sir, what is the reduced mass? Mu. Mu is equals to, I can write capital M into small m by, it's a m plus m is the formula for reduced mass. Okay. So m mu r cube. So from this is what? Mu r cube omega square is equals to ze square by 4 pi epsilon naught. Okay. So now we can write m r cube omega square is equals to ze square by 4 pi epsilon naught. And next one, from the Bohr's theory of the quantization, if you talk about this one, quantization means what? For the angular momentum. Okay. So just let us see. Now, so from next one continuation, from Bohr's theory of quantization, it's a quantization. Bohr's theory of quantization. So what is the Bohr's theory of quantization? A quantization of angular momentum. It's a angular momentum. Bohr's theory of quantization of angular momentum. The total angular momentum is what? Okay, we can write it as this. It's a total angular momentum. Angular momentum. Total angular momentum is equals to L is equals to what? L1 plus L2. L1 is what? One is due to electron, one is due to what? Nucleus. So L is equals to I1 omega 1, or both of them have the same angular velocity, I1 omega plus I2 omega. So this is equals to NH by 2 pi. I1 omega plus I2 omega is equals to NH by 2 pi. So we can write as this. So L1 means what? I1 is the moment of inertia. Okay. So it's a moment of inertia. So moment of inertia of electron. It's a moment of inertia of electron. Same as moment of inertia of nucleus. It's a moment of inertia of nucleus. So now I can write this is what? L is equals to I1 omega plus I2 omega means what? Moment of inertia general formula is what? mr square, mr square. Okay, r means r1 square. So this is what? mr1 square and into omega. Next one, I2 mr2 capital M into r square into omega. Okay, so now come to this. So now mr1 square into omega plus, okay, next one is capital M into r2 square into omega is equals to nh by, it's a 2 pi. Okay, nh by 2 pi. So now we can go for this. What is r1 and r2? Already we did this. It's a small letter m times of r1 means what? Capital M. Okay, r by m plus m whole square. Okay, so this is whole square into omega plus next one, it's a capital M into small letter m, small, so r2 means what you say here? Small m, r by capital M plus small m whole square into omega is equals to nh by 2 pi. It's a nh by 2 pi. So Next we can go for this. It's a m into capital M square r square by capital M plus small m into omega is equals to m into small m square r square by capital M plus small m whole square into omega is equals to nh by 2 pi. Okay, so this is the relation. So here we can write it as this one. Small m some terms will be getting cancelled. Means common we need to take about from this. Okay, so just you take the common. Common is what? Small m. Next capital M. Next r square omega by, it's a capital letter M plus small letter m. So small m, capital M, one m is left. Next one is what? M. Next one is from the second term, small m is left. Small m and capital M, first and second terms, is equals to nh by 2 pi. This cancel. Okay, so these will get cancelled. Then finally we can get it as this from here. It's what? Square now this. Oh, sorry, it's a square. This is what? Square. So square term will be cancelled. Square term will be cancelled. So finally you will get it as this. This we can write, it's a mu r square omega. Mu r square omega is equals to nh by 2 pi. Mu r square. Sir, what is the mu? Reduced mass. What is the reduced mass? Small m into capital M by small m plus capital M is the reduced mass. Mu r square omega is equals to nh by 2 pi.